Okay, what's up guys? It's me Cyber Junior again here. Today we'll be learning on how to make a ransomware virus. For those who don't know what a ransomware virus is, this is a virus that is able to encrypt your files, text files, all kind of files, and after it has encrypted your files, it will then ask you for a key to decrypt them back to the original data. If you don't have the key, then that's it for you. You will have to pay in Bitcoin or in raw money to a certain server or to a certain person, and then you will get back your key, and then after you enter the key, your data will be decrypted back. Now the data that has been encrypted might be very crucial data, maybe on an organization's data and all that. The data comes in wide range, for example text files, Python files, C files, exe files. It comes in a very wide range, so it's a very deadly virus. So let's first go ahead and see what are the libraries that we first need. First we'll needing a library known as cryptography. Okay, if you don't have that, you just have to do pip3 install cryptography. Okay, sorry about that, cryptography. Yeah, so that is how you do it. For me, I already have cryptography in my laptop. You can see that the installation, because of all that, it is actually the requirement is already satisfied, so that is great. And I think that is the only library that will be needed to download. So let's go ahead and start our thing. So for today, what we'll be doing is that we'll be making this ransomware virus, and with this ransomware virus, we'll be encrypting all the files that are in our desktop, but not just all files that are text files. I will also show you how you can find all the files that have the extension .txt in our desktop. Okay, so let's go ahead and fire up our text editor. For me, I'll be using Visual Studio Code, which is a very good code also, and it is a very good app for programming with different languages. Okay, all you have to do is just come into the extensions area and download the extension for the language that you want to code with. Okay, but that's a lesson for another day. Let's go ahead and actually, before we start, let's make a directory in our desktop. So without wasting time, let's head over to our desktop. Let's make a directory in there, and we'll call that ransom like that. Ransom. Then if I were to go inside my ransom, you can see that there is nothing, and if you move over to my desktop, you can see that the file ransom. So let's go ahead, and because this is a Python file, you have to write that it's a Python file. Also there you'll have to pick the place where you'll be saving it. In my desktop, and it's in the ransom file. So the name of our file will be ransomware. Okay, .py. Okay, .py. Or let's not do ransomware, let's do encryptor.py. Okay, like that. So that's the name of our file, and then we'll also have to make a second file, which is which will also be a Python file, and its name will be decryptor.py. So like that. So we have encryptor and we have decryptor.py. So that is how it works. So let me just explain how it practically works. Now when you actually have been a victim of a ransomware attack, is in that you have opened a file which had been affected by this virus. Now when this virus actually runs, it's that it will lock everything in your computer, and it produces a certain key. Then this key is sent to the hacker who was targeting you, and he only has the key. Then the file deletes itself automatically, and you are only left with the decryptor. Now what the decryptor needs to work is that it needs the key. Okay, it needs the key that was actually produced so that you can decrypt the data. If you don't have the key, there is nothing that will happen. If you try decrypting it with a different key, then you'll be given an update that the key that you are trying to decrypt with is not working. So it's like of sound like networking. But for today, I will not be showing you the full server thing. If you want to learn the full server thing, just go on to Cyber Genie and try, and I've already made a video for that. Just see how full ransomware works. So it will be ransomware part 2. This is just part 1. So this will only give you the basics before we go to the networking area. Okay, so what I will do today is that I will actually generate the key. After generate the key, I will write the key inside a file. After write the key inside a file, what I want to do is that I will enable the decryptor tool to read the key that was written inside the file, and if the key is not correct, then the decryption will not go on. Also, I will make some few text files in my desktop and will experiment with that. For now, I don't want to experiment with Python files, maybe other files, because that may cause my laptop to, my operating system actually, which is Linux, actually to misbehave. So yeah, it's also actually very dangerous, or very good that when you are coding these, you should also be very careful with what you are writing, because you don't want to mess with some of the most important files in your laptop. Most of Python files, keeping into consideration that your laptop or the Linux operating system is actually coded in Python files. So let's go ahead and now we are actually coding our encryptor. Okay, let's go ahead and import all the libraries that we need. For first, we'll be doing from cryptography. Okay, from cryptography.fornet import, and we'll be importing fornet. Okay, like that, and then we'll also be importing OS, like that. So for now, those are the two libraries that we'll be needing. I'll just show you how we'll use them. So first, let's actually generate the key, and I will just store the key that I will generate into the variable key. You can choose your own variable. So key is equals to fornet dot generate key, like that. And then for now, I'll just print the key so that I can show you how the key actually looks like. Okay, so if I were to run my file here, you can see this is how the key actually looks like. You can see how it looks like. This is how the key looks like, and actually all the time that we run this, we will be getting a different key, actually a different looking key. The key will not be the same. It's just a random key that will be produced every time and now and then. So if you just look at that again, a different key has been produced. You can see it is producing different keys. These are the keys. It is actually in byte form. Okay, so this is not plain text, but our key is in byte form. So let me just clear that and let's continue with writing. So now that we are able to produce the key, let's write our key inside our file. So I'll just open our file with open, and the file in which we'll store the key should not be a text file, rather it should be a key.key file. Okay, the extension should be .key, not .txt. Okay, so that it can be able to read that it is key, and also it will enable you to write bytes inside a .key file. Okay, so we are writing bytes this time. We are not writing any plain text or all that. And I will open it as key file. Okay, and then right here I'll do key file.write, and inside here, what are you writing? You are writing the key, like that. So what we did there is that we produced a key, and then the key that is the key that we'll be using to encrypt our data with. So the key that we'll be using to encrypt our data with will actually be written into our file. And also you have to remember that the key that you have encrypted with should be the same key that you decrypt with. If you actually mess up any of those keys, maybe you run the encryptor twice and the decryptor runs once, then there will be a problem. Okay, you must be very careful when running these programs. Okay, so next, because as I told you, you must be careful on what you're doing, we'll first go ahead and make enable us to I will just create a password, my own password, which will enable me to continue ahead. But if you want, this is not a must, but you can just do it. Okay, but okay, let me not do it because it will be somehow, because or you can just do it. How you can do it is that you can do it like this. You can just do the following. You can do, maybe you can input the username. For example, you can just maybe say security. Okay, security is equals to input, and then you just say password. Okay, password, like that. Now, and then you will have to say if password is equals to this, then continue. If the password is not this, then don't encrypt. So, but for now, that is not very important. Next, what we will have to do is that we will also have because remember that we will be running this in a computer, and If for example we are to do this on a Windows 7, but I'm not saying that we should do this, actually this for educational purposes. If you are to do this on a computer which must saw Windows 7, you'll have to specify the username. Why? Because maybe your username is Kali or Cybergenie, but that is not the same username that another machine has. Maybe the username there is Alex, Joseph, underscore Alex, all that. There are many usernames now. So we'll also import another library which we'll do from get a pass import get user. Okay, now this will help us to get the username of the computer, or the username who is actually currently operating the computer. So to do that, we'll have to go ahead and do username. We just store the username in a variable username. So username is equals to get user, and then we'll do that. And for now, let's just print the username and let's see what we'll get. For now, we'll just get something like my Cybergenie, because that's my username if I'm not wrong. Okay, my username for now is Kali, so you can see it's Kali. Yeah, there it is, it's Kali. That's my username, that's why I got Kali. Okay, for you, you'll get a different name. And also the reasons why you need, even though I will be running this is in my Kali Linux machine, the reason as to why you need actually to make this to get the username is because in Windows you will have to specify the path, and I will just show you the path that I'm talking about. So before we actually start doing, let me now get the username, because we'll actually need this username equals to get pass get user action. So with those 4 lines we are able to produce the key, and we are also able to get our username, which is perfect. So let's go ahead now and search for all the files in our desktop that end with the extension .txt, and this is how actually you search for them, or search for files with a certain extension in a certain path. So to do that, you do for root, okay, and then you have dir name, okay, directory name, okay, and then you also have files, okay, in os.walk. So you are using the os.walk function or library to try and go through all the from the root, the directory name, to all the files in the desktop, to the path. Now this yet we have not defined where we want to search for the files, but I'll just show you. So to do that, you have to do the following. We want to search for the files in, maybe let's do, because this is a Linux machine, we want to go home, and then you want to do, okay, now inside here you will do like that. You will just leave, actually that's how you write, you just leave some curly brackets in there, and then you just write that you want to go to the desktop like that, which is perfect. Because if you are to go right down there and maybe you go to the desktop, let me just show you. If you actually were to copy this, you can see how it is written home, and then you have the username right there. That is the thing that will be changing, because maybe the username is Alex, and then you have desktop. So just place it the way it is, just like that. Okay, so you have os.walk, you will walk in there, okay, and then after you walk there, you have to do, so for file, in files, okay. Now if file dot ends with, okay, this is what you do. So for all the files, in all the file, so for file in file, so this will actually enable all the files in our maybe desktop to be stored in the variable file. And now we have to do it to say if file dot ends with .txt, because that is the last extension. Okay, let's print the full path of the file. Okay, let's try first and print the file. Okay, so I'll just head over to my desktop for now. When I head over to I'll just make a file right there, and I will call it names, okay, names.txt, okay, like that. And then I will make another file right there, for example passwords.txt, okay, like that. Let me just make those two. So if you are to run this, just watch what will happen. Okay, for now, so for file.end, okay, for now it's telling me that there are no files. Let me just run it through the quick way. Okay, let me see. Okay, that is desktop, home, username, get user. So Oh yeah, sorry about that. I have not yet defined what these brackets stand for. So that will be the format, and inside there will be the username. Okay, so let's now run that, and let's run that. So you can see that I got the two files that I just made, which is names.txt and passwords.txt. You can see that we have found all the files that are in our desktop that have the txt dot something. But you see now, if we started opening these files, because actually in a ransomware we don't just specify that, we actually go for more specific data, or more important data, for example in the cities and all that. So you don't just go the desktop. And now if we were to open the file, because we need to open the files to read data, and we just if I opened it using in this way, let me just show you what I mean. If I were to open the files, and this is actually a bug in when you are typing this kind of ransomware. If you do the following with the open, because now you have done that, if you try and open the file with open file in read bytes, okay, as original file, okay, original file. If you try and do that, and then you do maybe data is equals to original file dot read, okay, and then you try and print the data. Now sometimes when you do that, let me just write something inside the text file. Let's try and write something inside there, like programming, okay. Programming in Python is the best. Okay, let's try and do that, and then we just close that, and then I come in and also write something in this file. So let's also write my password is maybe commander at commander. That cannot be my password obviously. So that's how we write that. Okay, so if now I were to run this, because we were expecting to read data, you can see that you are getting an exception right there, that with open file as read by as original file, it is telling you that no such file or directory names.txt. And you can see that that is a problem with that, because this is a problem that occurs very much. So to cater for this problem, what we will have to do is that we will have to provide the full path of the file. So what we will have to do is that after you have said, if after you have written the line if path file dot ends with .ext, you will have to write to do that file path. It's up to you to use your own variable. File path is equals to the following: root, okay, root plus let me just put that in there, root plus file, okay, like that. And then if I were to print the file path for now, let me just clear this, and I'll show you what that will give us. So you can see that that is giving us the full path. Actually, let me just remove this last, like that. So if I now run it, you will get a better, clearer. There you go. You can see that you are now getting a full path. You are getting that all the files that are in our desktop, and it is the path is on curly desktop names.txt and all that. So now if we open the file, let me now not print. So now if I open the file, it will not give us any problem. So this is the problem solved. This is how you solve such a problem. So with open file, now we are opening file path because we have the full thing, and we are opening it is in read byte data form, so as original file, okay, and then you will have to do that data is equals to original file dot read, okay, and then let's try and print the data inside there. So let's try and run these, and let's see whether we will be able now to read the data inside. And there you go. You can see that you can now read the data. The first file we wrote in is that we wrote the following: programming in Python is the best, and the other one is that I wrote my password is commander. So you can see that that is a problem solved. That is why many of the times when you try and code in it, just as I decoded it at the first as the first way, you'll get an error, okay, because you must specify the full path of where you want to search for, or the file where the .txt file is. You must give the full path, and that is gated by the following: file path is equals to root slash plus file, okay. That is how it works. So now that we are able to read the data in that, so what next? Now we don't have to print the data. Now that we are able to print the data in that, what we'll have to do is that we'll have now, and after we have read the data in byte form, we have actually stored it in the following. We have stored it in a variable known as data. So next is that we'll have to say that k, you can use your own variable. K is equals to farnet, okay. Inside here you have to enter the key that was just produced. And then next, what we'll have to do is that we'll have to do encrypted data. You can use your own variable. So for me, I'll do encrypted data is equals to k dot encrypt. Okay, now we are encrypting, and what will you be encrypting? You'll be encrypting data. After you have encrypted the data, now you have encrypted the data. That is true. But all you have just done is that you have just read the data, stored it in a variable as data, and now encrypted the data. Now you need to write the encrypted data back to the files. But if I were just to print the encrypted data, that will just show you what the data will look like when it is encrypted. Okay, so let's just run that, and then you can see now that actually it has actually helped me actually show you what I want to do. So for example, you can see that the first line was programming Python is the best, and this is what you now get. Okay, something that you even no longer understand what it is. Second line is something actually different. Okay, that is what now we want to write back into our into the files. Okay, we want to write that into the original files. Remember, you just read it, you never wrote the encrypted data. So let's go ahead and open the files again. So with open file path, okay, so you are now opening the files a second time, and this time you will be opening it in write bytes. Remember, the first time as you had opened it as reading bytes, you had opened it in reading mode. Now we are opening it in write mode, okay. And now we'll open it as an encrypted file, and then we'll do encrypted file dot. Now we are writing the encrypted data that you have already encrypted, okay, encrypted data like that. So yeah, that's actually it. That's actually the ransomware. The 23 lines of code ransomware. Now what we just did is that we opened the files again, and then we now wrote the encrypted data, because this is how it works. When it opens the first file, which is names.txt, it reads the data, it encrypts the data. Maybe let me just paste that. Okay, it reads the data, it reads the data, it encrypts the data, then it writes the encrypted data back to the file, to the original file. So we are not making a duplicate, but actually writing into the original files, which is very a better way to go for a ransomware attack, okay, because you don't want to duplicate the file, okay, you just want to go for the original files, and that will give you less errors and all that. So for now I will not run it, because actually if you actually open one of my files here, you can see that it is not yet encrypted, okay, it is not yet encrypted. The reason as to why it is not yet encrypted is because I had not written the data yet. Now the reason as to why first I'll make the encrypted, because this time the key will be produced for real, okay, and the key will actually be saved inside the file, okay. Now the reason as to why I make this key file, is because I want the decryptor to read the key from that, okay. But if I was to do this fully, I would make a server which will send over the key to me perfectly, okay. But for now, all that I want to do is that I just first want to make the key readable from a file within my desktop or within my computer. So okay, yeah, I actually coded the decryptor. So the decryptor in our case is our encryptor. I actually forgot, but don't worry. So our decryptor will be working as our encryptor. So let me just change. I don't know if there's. So let's just continue. So our decryptor is our encryptor. I actually confused that. No worries. So our encryptor, just keep in mind that these are encrypted. So let's now write our decryptor. Okay, in our decryptor the process will be the same. We'll have to import, we'll have actually right here you have to import that from cryptography.farnet import farnet. Okay, and then we'll also have to import os. Okay, also you'll have to import from get pass import get user. Okay, like that. And then you'll have to do that. You'll have to open the file that you have written the key into, which will be with open, and you will have to know the name of the key. For me, I just specified key.key, and it has been saved in my directory whereby I'm working in, which is the ransomware. You can see there it is, so I don't have to specify the full path for that. And I will open it in read byte mode because the key has been saved in bytes mode as a key file. And then after that I will do, sorry about that, it should be s, I forgot the s key file. Okay, and then I'll do key file dot actually I'll do that. I'll store the key in a variable known as key, so key is equals to key file dot read, like that. So there we go. Okay, if I were just to print the key, you will just find the key that was produced when we were actually trying to do that. So you can see this is the key that is there, this is the key that is right there inside there. This is the key that was used actually to encrypt this data, because we have not yet written the encrypted data into our file. So this is the key that was used to encrypt this data. Okay, hope you now get it. So for now we don't have to print it, all we need is just to read it. So we have now read the key that we are going to be using for decryption. If this was going to be real, as I'm going to do next time, we'll not be needing the key file, but all we'll be needing actually is just a server, and I will show you how we'll be doing that. So what we will do next is that we'll go we'll now actually find all the files in the desktop, because those are the files that we have encrypted. If this could be you just give the same path, okay, to where the encrypted files are, okay, because you are the attacker, you obviously know that. Okay, so we go for root, dirname, and files in os.world. Inside there you give the directory which be home. I just forgot to, let me just do that then. So username is equals to get user, like that. So that will enable us to get the user, and then inside there curly brackets. If you want, you can just write username here, but that means you'll have to insert an F string right there, but I don't want that. And then you have to go then to the desktop, because as I told you, as a hacker, you know where you actually put that. And then after there you do dot format, and then you say that those curly brackets actually mean username. And then you will go for file in files, if file dot ends with .txt. Okay, if the file ends with .txt, you want to get the full file path. So file path is equals to root. Okay, and then you'll have to do a plus, like that, and then you have to plus file. That will give you the full file path to all the text files in your desktop. Okay? Because you will have to provide the full text file path as I told you. So you have already read that. So let's go ahead and open those files. So with open, we're opening the file path. Okay, so with open file path is read bytes. Okay, now we are read, because remember the encrypted data actually is in form of bytes. Okay, let's do as encrypted file, because that is the file that has been encrypted. Let's do data is equals to encrypted file dot read, like that. So all the data that was has been encrypted, already been encrypted, is now stored inside the data variable. Next is that we'll have to go ahead and decrypt it. So you can use your own, you can use D. Usually let's use D is equals to and format. Okay, so it's now the key. If this was to be the full ransomware, how it actually works is that we should actually read this from the user. Whatever key the user will insert there is what will now inside the format curly brackets. We have to do that decrypted data is equals to d.decrypt. You can see it is giving us that option, the decrypt, and what will be decrypted is the data. So now we have decrypted the data and we have stored it in the decrypted data variable. Okay, so we now open the files again, but file path, but now we open the files in write mode. Okay, now this is after the person has already paid the money and he has now actually he or she has received the key, as we'll open it as the original file because it has already been decrypted. Then we want to do original file dot write. Inside there we'll write the decrypted data. Okay, yeah, that is what we'll write there. You will write the decrypted data, the data that was just decrypted, and that's it actually. So that's our decryptor, and that's this is our encryptor. Our encryptor has around 24 lines. Yeah, 24 lines actually. Our decryptor has 23 lines. Mostly because of this extra line whereby we have to generate the key. So here we don't have to generate the key, we already generated the key. So let's go ahead, maybe let me show you what I mean. So I will just open one of my files which is names.txt, and actually I will trust that. So great, so that is one of our files. Okay, so let me just go over to my terminal and head over to where my files are. So my files are on the desktop. If I do an ls right there, I'll see them. That will be ransom. Then I do an ls. Then I have to give them the permission to be copied and all that, but don't have to do that. So you can see there the year. What we do next is, okay, remember that our decryptor.py is our encryptor. I actually mixed that up. And then our encryptor is our decryptor. Okay, so yeah, because you can see our decryptor is what actually encrypts, so don't worry about that. So let's go ahead and run. Before I run that, you must check whether everything is good. Mostly if you're doing these of a large or of if you want to if you're practicing this in Windows machine or in any machine, you must be very careful not to mess up with your data. So for me, if I check it, it's okay because this is our encryptor, so we are writing the key, and in our decryptor we are actually using the key. So let's go ahead, let's run and hope for the best. So let's go ahead and run our decryptor because that is actually what will encrypt our data. So our decryptor is our encryptor. I hope that you get that. That should be decryptor. So also I would like, if the data has been decrypted, let's print something. Data encrypted successfully. So that will actually tell us that okay, your data has been successfully encrypted, which is great. So you can say it's about 25 lines of code. It's enough. And also in our decryption, let's do print data has been successfully decrypted. Okay, like that. So 24 lines of code in our decryptor. So let's go ahead and run our encryptor. And in 3, 2, 1, There you go. And actually, if you check the file, the inside of the file, my names.txt, it has just been encrypted. You cannot understand. Let me just open that again so that you can see. If I open my passwords.txt, you can see it is all encrypted. You even don't get what has been written inside there. So you can see what has just happened. Our data has just been encrypted, just like that, just quick like that, just that quickly. Our data has already been encrypted, and there you can see that that data has been encrypted successfully. Time to run our Python, our decryptor. Okay, don't let the names actually mess you up. Decryptor.py. So Python encryptor.py. It just told me that the data has been successfully decrypted. Okay, so let's go ahead and check whether our data is back. And there you go, your data is back. Okay, how good. So for those who may think that I'm just bluffing, let me just run these when you're just looking at that. Sorry about that. So this is the data that you'll be looking out for, whether it will change or not. So let's go ahead and encrypt that. So let me just clear that. So let's run our Python 3 the encryptor. So my encrypted the decryptor, I just messed it up, so don't let it confuse you. So decryptor.py. So let's go Python 3 decryptor.py. So in 3, 2, 1, there you can see that my data has actually been encrypted. Nothing is something that you even can't read. You can't understand that is H or whatever. Let's now run our decryptor, which is which I've given the name encryptor. So Python 3 encryptor.py. So in 3, just look at how the data will behave in 3, 2, 1. There you can see you're just changing it, toggling it. If you lose the key, if the keys don't match, then you're in a deep trouble. But you're just trying. So, but if you lose the key, it's not good to lose the key. So that is what I can do. You can just keep on playing with that. Running the decryptor, it will pick the data. The data has been encrypted successfully. You run the decryptor, that has been successfully decrypted. You can just keep on playing with that, play with it. And you feel it's your time. But next time I will actually show you the full way that you can actually make actually how you should actually code it so that it can be pretty great and all that. So I hope that you enjoyed and it was fun. So try and check out my next video on how to actually build the ransomware part 2, and you'll be able actually, oh my god, did I decrypt that again? No, let me just see. And you'll be able to see what I mean. So yeah, so hope that you understood. Please actually just do this for educational purposes. Do not do this for any bad purposes, because this is not if you are caught, you will actually be jailed. And do not say that you learned this from me, because I also don't know you. But what I will tell you is that please subscribe even if I don't know you. So yeah, that's what I just wanted us to learn today. For today, hope that you have learned everything well. See you until next time. Thank you. So yeah.